Okay, before moving on with the rest of the section, or at least this part, let's cover what we have learned so far. So here's our equation for the reaction y goes to x. The equation would be delta G equals delta G standard plus 5.9 log of concentration of x over concentration of y. Now we know that if we have the same concentration of x and y, so if concentration of x equals concentration of y, then this part right here will equal to 0. So delta G will equal to delta G standard. We also know the following, that if delta G is bigger than 0, then the reverse reaction is favored. So for y goes to x, actually this direction is favored. Whereas if delta G is less than 0, then the forward direction is favored. Now, this is delta G. It's not telling us whether this reaction is exothermic or endothermic. We're just saying that at whatever concentrations y and x are, if delta G is larger than 0, then the reverse direction is favored. Whereas if delta G is less than 0, the forward direction is favored. But that leaves us with one little thing that we haven't considered. Well, if delta G is greater than 0, we know what happens. If delta G is less than 0, we know what happens. In the case of delta G being greater than 0, the reverse reaction is favored. In case of delta G being less than 0, the forward reaction is favored. Well, what if delta G equals 0? Because that is the only number we have not considered. Well, if delta G equals 0, then the reaction is at equilibrium, where y goes to x is going in the forward and the reverse direction at the same rate. So neither forward or reverse reaction is favored. The reaction is making y goes to x the same amount that it's making x goes to y. So it's like nothing is happening. So the ratio of the concentration of product, in this case x, over y at equilibrium when delta G equals 0 is called the equilibrium constant, or K. So when delta G equals 0, the ratio of product over reactant, in this case x over y, concentration of x over y, will equal to the equilibrium constant K. Now let's go again back to our original equation. Delta G equals to delta G standard plus 5.9 log of x over y, right? Concentration of x over y. Now, if we are at equilibrium, so at equilibrium, where delta G equals 0, because that is the definition of equilibrium. You are at equilibrium for a physical or a chemical process if delta G equals 0. That's going to always be the case. That will never change. Remember, this is delta G, not delta G standard. So if delta G equals to 0, then our equation becomes the following. 0 equals to delta G standard plus 5.9 log of x, the product, concentration of product, in this case x, over the concentration of the reactant. Now, at equilibrium, x, concentration of x over concentration of y, equals to the equilibrium constant. So now our equation becomes 0 equals to delta G standard plus 5.9 log of K, the equilibrium constant. We're going to go ahead and solve for K. So to solve for K, what I'm going to do is I'm going to move this over here first. I am subtracting 5.9 log K from both sides. So what I'm going to get is the following. Negative 5.9 log of K equals to delta G standard. Now, I'm going to multiply both sides by negative 1. So now I have 5.9 log of K equals to negative delta G standard. Now, I'm going to divide both sides by 5.9. So I have log of K, again this is big K, equals to negative delta G standard over 5.9. Now what I'm going to do is I'm going to take both sides and put them to the base of 10. So what I'm doing is this. I am literally saying this to the power of 10 and this to the power of 10, like that. So I'm going to write it out. So we have 10 to the log of K equals to 10 to the negative delta G standard over 5.9. Now, any number, we're just going to do it to the side. 10 to the log of x will equal to x. Okay? So, and that's what we have here. So, this is going to become K equals to 10 to the negative delta G standard divided by 5.9. Now, why did we go to all this trouble? Because we know that this K is the concentration of product, in this case X, over reactant, right? Now, if my delta G standard is a negative number, so if this number is negative, then this thing right here would be a positive number, and then my K will be bigger than 1. Because 10 to the power of anything that's positive will at least be bigger than 1. But if my delta G standard is a positive number, this thing now that we have circled in red will be a negative number, and then we'll have a number less than 1. We can plug in a number just for fun. Let's assume delta G standard equals to negative 5.9. Then if I plug negative 5.9 in here, what I'll get is K equals to 10 over positive 1, and that is just 10, right? So again, now we can say that at equilibrium, the concentration of X over Y will equal to 10. Now let's assume that our delta G standard is negative 1, and these are going to be in kilojoules per mole. We have to keep that unit because otherwise this will not work. So kilojoules per mole here too. I apologize for not putting these in earlier. Now what I will get is K equals to 10 over 1 over 5.9. And this will give me 1.48. It's 1.477, but we'll just go with 1.48. You can see that the ratio of X to Y is still bigger than 1. So if delta G standard is less than 0, then K will be greater than 1. Now, if you do the same calculations, but you change the sign, instead of negative 5.9, you put 5.9, instead of negative 1, you put 1, what you'll see is that your k will be less than 1. We're not going to do that here, but you can do the calculations yourself. It's really straightforward. So if delta G standard is greater than 0, then k is less than 1. So if delta G standard is less than 0, then k is greater than 1. This is a favorable reaction, or exothermic. If delta G standard is greater than 0, then k will be less than 1, and this is an unfavorable reaction, or endothermic. Right? So when we say a reaction is favorable, we mean that at equilibrium you will have more product than reactant. If it's unfavorable, we mean that there's going to be more reactant than product at equilibrium. And if we know the delta G standard, we can know what the K will be like. If we know what the K is, the equilibrium constant is, we can know what delta G standard is. Why? Because in our equation that we have, the one that we're going to be using here, let's go back up here. Yep, here's our equation, right? There are really 4 unknowns: x, y, delta G standard, and delta G, right? Well, if you know delta G standard, if I'm telling you this is the delta G standard and you know it, well, you know that at equilibrium, delta G will be 0 and the log of x over y will equal to the equilibrium constant. So you basically get rid of delta G because you set this to 0 right here. And then you have your delta G standard, you plug that in, and then you solve for x over y, which is your equilibrium constant. If you know your equilibrium constant, then you know that, okay, how do I figure out delta G standard if I know my equilibrium constant? You set delta G to 0, you plug in your equilibrium constant for x over y, then you solve for delta G standard, like I think we did below. But the main thing is that delta G tells you the direction that the reaction, whether it's a physical reaction or a chemical reaction, favors at the moment, based on what the concentrations of reactant and product are. Delta G standard and the equilibrium constant, what they tell you is whether this reaction is favorable or unfavorable, meaning that at equilibrium, do you have more product than reactant, or do you have more reactant than product? Okay guys, we'll end this video here, and we will continue with the rest of the section next time. Thank you.